Selam herkese 4. bölümden. Burada Memory Management'dan devam edeceğiz. Bir önceki bölümde burada kalmıştık. 102. sayfada. Şimdi devam edeceğiz. Sadece birkaç değişiklik var burada. Bu Obsidian diye bir araç var. Desktop uygulaması. Burada ben notlarımı bu şekilde alacağım. Sağda gördüğünüz gibi yeni tab açılmış. Solda da kitabın devamı olacak. Sadece arayüz olarak tek fark bu olacak. Obsidian kullanmayanlara da öneririm. Çünkü hem not almada hem de kişisel yönetimimiz açısından kolaylık sağlıyor birçok konuda. Faydalı buluyorum. Şimdi Memory Management'a devam edelim. Tabii bir önceki bölümü şöyle kısaca bir özetleyelim. Neler konuştuk? Linux tarafında File Descriptor diye bir konsept vardı, onu konuştuk. İşte standart input, standart output ve standart error diye. Bunların her birinin bir numarası vardı. Onları gördük 0, 1, 2 diye. Onun haricinde concurrency modelleri ve bu concurrency modellerinin hangi programlama dilinde nasıl çalıştığını görmüştük. Örnek veriyorum Node.js'de event loop'lardan, event mekanizmalarından bahsetmiştik. Ardından ne bileyim Go'da nasıl çalışıyor işte bu Coroutine'ler veya PHP FPM'de nasıl concurrency ve I/O modelleri var, onları gördük. O başlığın ben önemli olduğunu düşünüyorum. Eğer izlemeyenler varsa orayı öneririm. Başka ne konuştuk? Stateful ve stateless uygulamalar neler? Onları gördük. Örnek veriyorum işletim sistemi tarafında bir proses de stateful ne demek mesela? Bir proses herhangi bir şey saklıyorsa proses öldükten sonra, yani proses işlemini bitirip kapandıktan sonra bir şey saklanıyorsa buna stateful diyorduk. İşte örnek veriyorum PHP FPM gibi proses başlatılıp işlemler yapılıp proses executed olduğunda geriye kalan her şey siliniyorsa memory'den buna da stateless diyorduk proses bazında. Bunları görmüştük. Genel anlamda genel konsepte devam ettik. Yine aynı şekilde yine devam ediyoruz. Ama tabii mesela Memory Management'ı bir önceki bölümlerde de görmüştük ama bu kadar detaylı görmemiştik. Bu bölümde daha da derinleri ve detaylı göreceğiz. Derinleri ineceğiz. Bakalım kitap bizi nereye kadar sürükleyeceğiz bu şekilde. Genel konsept çünkü bayağı sürdü. Aslında bu da iyi bir şey. Çünkü programlama dili ve teknoloji bağımsız ilerlediği için bu konular genel anlamda iyi bir özet oldu. Bizim için de güzel bir tekrar tekrar öğrenme metodolojisi oldu bu kitap bu şekilde. Aynı bu konuları. Çünkü daha önce birçok kez görmüştük. Şimdi devam edelim. Memory Management. Ben hemen kendimi alayım buradan. Okay. Memory Management. We are not directly managing the memory when building an application with modern languages, since managing the memory is the most complex part of an application. But it is essential to understand two different types of memory used by our application. Tamam, modern programlama dillerinde, modern uygulamalarda memory management'a çok sık girmiyormuşuz. Zaten bizim için bunu kendisi handle ediyormuş. Ama bu iki tane memory kullanım tipi varmış. Onları anlamak önemli diyor. They are mostly used by two types of variables, local variables and global variables. Bize değişken tiplerinden bahsetmiş. Global değişkenler ve local değişkenler diye. Understanding this helping us to understand the difference of local variables, global variables and why memory leak happens. Ya bu ünlü bir sorun var işte memory leak diye. Onun neden olduğunu daha iyi anlayacakmışız bu konseptleri anlayarak. Yani çünkü memory leak dediğimiz şey, memory'ye bir şeyler atıyoruz. Sonra onları kullanmıyoruz. Ne oluyor? O zaman memory gereksiz bir şekilde şişiyor. Bizim amacımız neydi baştan beri? Zaten kaynak tüketimini azaltmak. Biz sürekli bir şeyler atıp ve onları hiç kullanmıyorsak ve onlar kalıyorsa orada çok saçma bir durum var demektir. İşte buna da memory leak deniyor. O yüzden bundan kurtulmanın yolunu önce bu neden bu var oluyor onu anlamaktan geçiyor. Bakalım neymiş. Şimdi stack memory ve sanırım heap memory. Tamam. Bakalım. A stack is used to pass variables into another function, save local variables and execute routines. The stack space is managed by the CPU. A program is executed on the stack. The stack is very fast to access. The size of the stack is limited by the OS. The stack space is freed up when function scope is existed. Tamam, bir fonksiyon başladığında orada tanımlanan değişkenler falan stack'te tutuyormuş. Fonksiyon scope'u bittiğinde ise oradan siliniyormuş tekrardan. Yani o space freed up oluyormuş. Tamam, şunu aslında şu şekilde not alabiliriz. Çünkü bunlar çok kısa ve basit bir şekilde anlatmış burada. Şunu bir büyük yapalım. Şuraya da bir alt başlık açalım. Mesela stack memory diyelim. Doğrudan şunu yazarız. Tamam. Neymiş? Stack'ler CPU tarafından yönetiliyormuş, stack space'leri ve çok hızlı bir şekilde accessible'mış, yani şeye göre, heap'e göre. Ne diyor? Program code, function variables, global variables. Tamam, programın kodu memory'de tutuluyor, fonksiyon variable'ları stack'te tutuluyor, global variable'lar stack'te tutuluyor. Dynamically allocated, statically allocated. Function stack frame. Okey. Genel anlamda memory modelden bahsetmiş burada. Heap memory. The heap memory is managed by the application. We can increase the size dynamically as far as there is a free memory on the server. Tamam. Heap memory ise bizim uygulamanın kullandığı alanmış. Bunu eğer boş yer oldukça artırabiliyormuşuz buradaki kullanımı dinamik bir şekilde. Stack'teki fark neydi? Stack'te belli bir işletim sistemi tarafından limitli yer vardı. Ayrıca bu CPU tarafından yönetiliyor. Ve çok hızlı bir şekilde ulaşılabiliyormuş buraya. Heap'te ise bu uygulama tarafından yönetiliyor. Bunu server'da boş memory yeri olduğu sürece arttırabiliyormuşuz bu kullanımı ve dinamik bir şekilde. Ayrıca bunun yöntemi de uygulama tarafına oluyormuş. Aslında oradan bunu da alabiliriz bu şekilde. Tamam. Stack memory ve heap memory. Başlıca farklarını görmüş olduk burada. Compared to stack, access to the heap variables is slower. Stack'e ulaşmaya göre heap'e ulaşmak aslında daha yavaşmış. It is always used to save global variables and status which are lasting along with the process or application. Ben arada bir kahve falan içiyorum da o yüzden sessizleşebiliyorum. Şimdi you can also free up unused heap memory by releasing the resources. When memory leak occurs, it is because more global variables are saved in the heap memory space without freeing up. Aslında global variable oluşturarak onları nerede tutarak? Heap memory space'e tutarak memory leak'e sebep oluyormuşuz. Okay. This situation is the same for any modern languages. Tabi bu sorun dil bağımsız. So it is important to understand and properly manage the life cycle of a variable to make sure it is freed up when unused. Okay. Memory management. In modern applications, most languages may execute the garbage collection process automatically for you. But if we keep adding global variables into the heap, the memory usage of a process is growing without control. The large local variable may also be saved at the heap and only save the pointers at stack. Tamam. Büyük lokal variable'lar heap'te tutulup onların sadece pointer'ları stack'te tutulabiliyormuş. Ama diyor burada global değişkenleri sürekli heap'e atarak memory usage of a process'i yükseltiyormuşuz, arttırıyormuşuz. Hem de kontrolsüz bir şekilde. Bunu aklımıza tutmalıyız mesela. Even if you have carefully managed the life cycle of variables in your application, memory leaks may still happen for various reasons. In this case, we may have to handle the memory leak by retiring the whole process and replace it with a new process. This strategy is used by PHP FPM. It terminates the PHP process after serving several hundreds of PHP requests. Tamam, PHP FPM'in nasıl çalıştığından bahsetmiş. Yeni bir request geldiğinde her defasında yeni prosese açıldığından o eski proseste tutulan bu artık kullanılmayacak olan değişkenler memory'den siliniyormuş. Tabi burada işte proses oluşturma maliyeti, bunların tekrar memoriye yazılma durumları ve bunların memory'den silinme durumları falan hepsi bir sorun ve maliyet. Bu da bir trade-off. Yani sonuçta PHP FPM ile Swool'u sürekli karşılaştıracak burada. Çünkü ikisi apayrı bir runtime sunuyor. İkisinin avantajları ve dezavantajları farklı. Ama düşünsenize sürekli aynı, yani uygulamanız çok az değişiyor. Sürekli aynı değişkenler var ama sürekli yeni bir proses oluşturuyorsunuz. Ya bu da çok gereksiz bir şey. Onun maliyeti çok daha fazla. O yüzden burada Swool öneriliyor mesela. Şimdi PHP FPM'de nasıl çalıştığını anlattı burada memory tarafında. Process, thread and coroutine. Ya bunları aslında çok sık gördük bu kitapta ama mesela biraz daha detaya girecek anladığım kadarıyla, bakalım. Linux process. The process is the most common execution container in Linux OS. When execute a PHP script, one new process is created by the OS and allocated memory and other resources can be used by the process. Okay. Each process has its own memory space to save global or local variables and context information. Doğru. Her proses kendi memory alanına ve global ve lokal değişkenlere sahip diyor. One application may associate with multiple processes. If the machine has multiple CPU cores, the process can be executed in parallel. Burada paralelle concurrent'ın farkını hatırlayacak olursak, paralel bir işin aynı anda yapılması, concurrent ise context switch'lerle birlikte aynı anda yapılıyormuş hissi veren bir yapı. Each process has a unique identifier number called PID. It helps us to find and identify the process. We can get this number with the function process_getPID. Okay, process_getPID diye bir built-in function varmış PHP'de. Bununla birlikte çalışan prosesin PID'sini alabiliyormuşuz. Tamamdır. Aslında şu da önemli bir bilgi. Ben bundan not alacağım. Linux process deyip bir uygulama birden fazla proses sahip olabilir, assign edilebilir ama CPU core ne kadarsa o kadar proses aynı anda çalışabilir. Tamam. Process forking and memory copy. In Linux, the process is able to create subprocesses or child processes with fork system calls. Fork sistem koluyla birlikte prosesler child'lara ayrılabiliyor diyor. When a child process is forked by a parent process, the variable and context information is copied as is. In the real world, it's more complex than just copy. So, modifying a variable in a child process won't change the same variable in the parent process. Tamam, birden fazla child process sahip olabiliyoruz ama child process'te bir şey değiştirmek parent'ı etkilemiyor diyor. Understand, tabi bu Linux proseste. Understand this is very important because in the multiple process structure, Swoole server, we shouldn't define a global variable in the main process context and expect it can be used across multiple worker processes. We should also not expect we can share a global or static variable across multiple worker processes. We will explain more how to share a global state across worker process with Swoole table in the other section. Tamam, birbirinden bazı proseslerimiz olacak. O yüzden global variable tanımlayıp bunları değiştirmeye çalışmayın diyor zaten. Bunu en başta da bahsetmiştik. In PHP, we can use pcntl fork to create a new child process. When executing this piece of code, you should see something like this. Ne diyor? Şu an çalışan PHP CLI'nin prosesini aldı, yazdı. Sonra bundan bir tane fork yaptı. Şey oluşturdu, subprocess oluşturdu. Onunkini yazdı. Bu hangisini yazdı? Tamam, bir öncekini yazmış. Sonra da tekrardan fork'unkini almış. Tamam. Okay. The PID in step 1 is the main process. 13789 buradaki bizim ana proses numaramız. Then the execution flow is branching out to be two-step within different process. The first branch is the main process itself. After calling PC and TL fork, the PID returned from the function is the child process ID. The second branch is the child process fork. The process has a different process ID. The result of PC and TL fork is 0 in the child process branch. We can use this to identify either we are in the main process branch or the child process branch. We can use the next example to understand memory copy. Tamam, memory copy konseptini göreceğiz birazdan. Bakalım. First, we define a variable a with value 1, then create two execution branches by fork a new child process. Next, within the child process, we modify the a to b2, then check the a value in the main process and child process. The result should be like this. Okay, bakalım. Şimdi A değişkenine 1 tanımladı. Bunun gitti PID'sini aldı ve yazdırdı. Sonra bunu forkladı. PID 0 ise yani şu anda child process'teyiz. A'yı 2'ye eşitledi. Sonra gitti bunun PID'sini tekrar aldı ve A'yı yazdırdı. 1, 1, 2. Tamam, şurada artık farklı bir proses olduğu için bu A mesela birden ulaşılamayacak birinci prosesten bundan sonra. We can see the main process with ID has a which is always to be 1 even the child process has modified A to be 2. Once a child process is forked, it copies every variable in the main process, then executes independent and isolates. Yani A'yı 2 yapmak main process'teki 1'i değiştirmedi diyor. In Swoole server, because there are multiple processes in the application, the variable changes within one process cannot be seen by the other processes. We should understand the server structure and know the variable scope to use correctly. Okay. Aslında şuraya ufak bir not daha alabiliriz. We can create sub-processes by forking the processes. Fork system call diyelim. Fork system call. Sub-processes will have copied variables of the parent process. Okay. Linux threads. Thread is a lighter weight executor compared with the process. Threads are created and scheduled within the process. In Linux, a thread is almost the same as a process. Ne diyor? Threadler daha hafif diyor diğer executor'lara göre, process execution'a göre. Threadler prosesler tarafından oluşturulur ve onlar tarafından schedule edilir. Linux'te bir thread neredeyse bir prosese eşitmiş. Ne demek bu? Bakalım. The major differences is threads are sharing the same virtual memory space and file descriptors, the same context of the process. Ana fark şuymuş. Threadler aynı virtual memory space'i kullanırken ve file descriptor'larını prosesler kullanılmış. Zaten bunu da baştan beri söylüyorduk. Şunu aslında doğrudan alabiliriz. Okay. Şunları da bir de tagleyelim. Tag memory'yi. Ya bu tagleme şey için, arama için falan güzel oluyor. Unlike the process fork, the memory copy, the memory between threads within the same process is not isolated. Tamam, process forklamadan ziyade threadlerde memory between threads within the same process is not isolated. Yani bir thread'de yaptığınız bir değişiklik diğer thread'deki değişikliği bir thread'deki yaptığınız değişkendeki değişiklik diğer thread'dekileri etkiliyormuş. Yani bunlar birbirinden izole değillermiş. One thread is aslında şunu da alabiliriz. Burası da önemli. Okay. One thread is able to modify a variable which can be seen and accessed by another thread. So synchronizing the access to the shared data within the process is very important. The context switch of threads is faster than processes. Although PHP has a thread version, few people use it in production. Tamam. The Linux threads are only used to process network I/O in Swoole. The reactor threads, ne diyor? Linux threadler network I/O'larını kullanmak için başvurulmuş Swoole'da. Reactor threadlermiş. From a developer's point of view, there is no thread API to create or use threads in PHP. The programming languages and frameworks using threads always keep a pool of threads and reuse them to reduce the threads context creation cost. Okay. Program dilleri ve frameworkler bu threadlerin yönetimini kendi başına yapıyorlarmış. Bu oluşturma maliyetinden kurtulmak için. Swoole PHP Coroutine. There is no concept of coroutine in either Linux OS or PHP. The coroutine we are talking about here is the coroutine function provided by the Swoole PHP extension. It is created within a process as a userland thread and scheduled by the scheduler of Swoole PHP. Coroutines are similar to threads or process but much lighter. The context switch cost is also low compared with Linux process and threads. Şimdi prosesler arasındaki context switch daha maliyetli, threadler arasındaki context switch daha ucuz proseslere göre. Coroutine ise Thread ile karşılaştırdığımızda daha da ucuzmuş. Yani daha performans çalışıyorlarmış context switch'te. Okey. Şimdi arka tarafta birkaç şeye bakıyorum. Okey, devam edebiliriz. Şimdi it is created within a process as userland thread by scheduler of Swoole PHP. Coroutines are similar to threads or process but much lighter. Tamam, buraları okuduk. Bakalım. Şu Swoole'un coroutine metotları. All the coroutines created within one process and okay, all the coroutines created within one process are executed independently. Even there may have nested logical relationship like the process tree. The child coroutines are not relying on the parent coroutine. These coroutines shares the same CPU time of the Linux process. The blocking system call in the one coroutine may block the execution of the other coroutines. Okay. Socket and networking I/O. Socket. The most important concept of networking in Linux OS is socket. You can connect two nodes on a network and communicate with each other with sockets. One socket listens on a particular port at a particular IP. The other socket reaches out to the other and establishes a connection. Okay. Şunu da alalım. Linux soketleri. Şimdi ben bunları tekrar daha sonrasında okurum. Şimdi the simplest socket server in PHP looks like this. Tamam, çok basit bir anlamda soketin nasıl oluşturduğunu ve nasıl bind edip dinlenebileceğini anlatmış. Sürekli dinliyor burada. Veya şuna bağlanıp mesaj gönderiyor sürekli. This is the simplest TCP server created with plain PHP code. There is no exception handling. It closes the connection when it has written the hello message. It can't serve multiple connections at the same time. When there is a blocking logic within the while loop, the server can't accept new connections. You can communicate with the server socket using a TCP client. We use NC here. When executing the NC command above, the server responds hello and disconnects the connection. Then serves the next request. We can also create a TCP client with PHP Socket API. Tamam. Ayrıca bir TCP client'ıyla PHP Socket API ile de TCP client'ı oluşturabiliyormuşuz. We keep it simple and have not implemented any exception handling logic. You can get the errors from a socket with socket last error in PHP, but we can see how two sockets communicate with each other and transfer data between them with this example. We can also see the singleplex concept and blocking concept from the example code. Everything is working sequentially, and the server can only serve one client at the same time. The PHP FPM server works similarly, but since it has to support concurrent connections, there are multiple worker processes. In one PHP FPM process, the process is sequential and blocking. The process could be idle and paused because one socket is slow and waiting. Okay. If one of your upstream services like database or cache is slow or has connection issues, the whole process and whole PHP FPM server is stuck and not responsible. In the example, the server is only writing data, the client is only reading data. But in the real world, one socket can read and write. Once the connection is established, two sockets can send and exchange data in a directional way. Karşılıklı bir şekilde veri sağlayabilmeliler diyor gerçek dünyada bunlar. Okay. Şimdi handling timeout and exceptions. There are two groups of socket API can be used in PHP. The first group is socket, the second group is stream. We will continue to use the socket API in this section. You can set up the TCP send or receive timeout with the function socket setup option. Some other settings are essential. Ya bunlar çok PHP'nin core kodları, yani core kod dediğim built-in fonksiyonlar olduğu için yani biz bunları gerçek dünyada kullanmıyoruz hiçbir zaman. Her zaman güvenilir ve sağlam üçüncü parti paketler ve library'ler kullanıyoruz. Çünkü onların community'si çok sık ve çok fazla özellikleri olduğu için bunları sürekli sıfırdan yazmak çok anlamsız. O yüzden çok önemli bulmuyorum şu an buraları. Ama basit anlamda nasıl PHP'de bunları yapabiliriz anlatmış. Blocking I/O and non-blocking I/O. Bakalım. You should have heard about blocking, non-blocking and async here and there are multiple articles or books. Tamam, sürekli duyuyoruz zaten bu blocking, non-blocking ve async kelimelerini. Her yerde. They may mean a different thing in a different context, but in the system layer, they mean the network socket mode either in blocking mode or non-blocking mode. Tamam. Yani non-blocking veya blocking kelimelerini duyduğunuzda her zaman aynı şey hayal etmeyin. Çünkü mesela sistem katmanında duyduğunuzla bir program dili katmanında duyduğunuz aynı şey olmayabilir. Bundan bahsetmiş. Bize sistem katmanından anlatacakmış bunları. Bunların anlamı network soketlerinin modlarıyla alakalıymış. Blocking mode ve non-blocking mode. Bakalım. Blocking I/O or non-blocking I/O is different depending on how we transfer the control between I/O handling in the kernel and calling thread. Blocking I/O only transfers the control is calling the thread when the I/O is ready. Non-blocking I/O transfers the control to the calling thread immediately and return the status. It is not blocked at the I/O operation. Okay. Blocking or non-blocking is how your userland code communicates with the OS kernel with the system calls. In non-blocking mode, the system call puts the request into a queue or buffer and returns immediately without waiting for the actual I/O to occur. The time spent on a non-blocking system call is just the time used to enqueue the request. Then use another system call to look up if the I/O operation is finished. If a CPU core is running at 3 GHz, it performs 3 billion CPU cycles per second or 0.3 nanoseconds on the chart. One non-blocking system call may take several CPU cycles, which is a few nanoseconds, compared with blocking system calls may take hundreds of milliseconds. The difference is 10 million times. Okay, network data set, non-blocking I/O system call. Non-blocking system call and full network request time'ın karşılaştırılması. You should have noticed in figure 26.2 the difference is 10 nanosecond and 100 millisecond. Okay. Make the socket non-blocking and multiplexing. Soketleri non-blocking ve multiplexing çevirmek. Multiplexing hatırlarsanız bir önceki bölümde görmüştür. Continue with the previous problem of building a server serving multiple concurrent connections. In order to serve multiple connections at the same time, we have to make the socket not blocking at the operation of only one connection. When a socket is in blocking mode, the process is blocked and at the operation like read, write, or connect, whereas if a socket is non-blocking mode, it returns directly and passes back the status of the operation to the application layer. Tamam. Non-blocking ise bir I/O operasyonu. Bunun sadece statüsünü döndürüyormuş uygulamamıza. Şeyde ise, blocked'de ise o proses bekliyormuş. O işlemi bitirme süresine kadar bekliyormuş. Tabi bu non-blocking'de statüs döndürdüğü için bizim uygulamamızda şeyi handle etmemiz lazım. Yani bu bitti mi bitmedi mi sürekli sormamız lazım. It may fail if the expected operation is not done or return the resource ID. The expected operation is done. Okay. Non-blocking I/O select. Bir tane context switch system call yapılmış. Geriye bir şey dönmüş. Select data readable, system call connect switch, data remove from kernel to user space. Okay. We can switch the blocking and non-blocking mode of a socket with function. Set block, set non-block. If the operation is not blocked at one connection, we can operate and manage multiple connections within one PHP process. To operate multiple connections, In multiplexing way, you have to use a loop to keep checking the status of multiple operations, checking mode of the socket with function. Okay. Dedim mi bunları hiçbir zaman yapmayacağımız için çok önemsemiyorum buraları. Geçiyorum hızlı hızlı. Ne demiş? Ne yapmaya çalışmış? We have switched the socket to be non-blocking and managed to persistent TCP connections. The logics are processed with one loop, including accepting new connections and process read-write operations on multiple clients. The other benefit of the non-blocking mode is it handles the external exceptions and is more reliable. For instance, TCP connection may take more than 60 seconds to time out. The read or write may be slow or unreliable networking. Your program may have other useful works to do. You may want to schedule the other task if one connection is slow. In non-blocking mode, the process is not waiting for one specific operation. Select. In the previous example, the application may still waste CPU cycles to check if there is data on the read, write, and accept operations. Linux provides a select system call to improve this. Select returns the number of read file descriptors or errors. We can improve the previous example with select. Select sıfırdan büyükse. In the example, socket select blocks the process and waits for any new connection, read or write event happening for 3 seconds. If anything interesting, moving down and filling in any socket is readable or writable into the array. Then we can operate based on which connection is connected or which connection has data to read from. New accepted connections are accounted as readable in socket select because in the request and response model, we know the socket should be writable. So keep it simple. We are not monitoring the writable connection and write data back straight away. A common pitfall of using socket select is the set to timeout to be 0. Then your process is looping very fast and may consume 100% CPU or put asleep within the cycle to save the CPU paths. The program is less responsive. Your process shouldn't be blocked except waiting for I/O events on socket select. Okay. Compared with the blocking I/O mode, when we read data, we only need one system call read. But in non-blocking I/O mode with select, we have to use two system calls, select and read. That is the extra cost of non-blocking I/O. So we have to keep in mind I/O multiplexing is not faster but helping us to manage multiple I/O with one process. If you don't have a large amount of connections on the server, I/O multiplexing could be slower compared with blocking I/O. Poll and epoll. There are some limitations of socket select or Linux select system call. We will introduce more about polls and epoll in the other sections. Epoll is used by all high-performance networking middleware and software on Linux such as Nginx, Aproxy, etc. HAProxy, etc. Summary. In summary, blocking I/O is blocking the process on one I/O operation such as accept, read, and write. Non-blocking I/O is blocking at the select, poll, and epoll operation, which are listening for any changes on connections. Blocking I/O is singleplex. Non-blocking I/O is multiplexing. When putting these I/O operations into our application logics, the application logic may execute in a blocking and sequential way with blocking I/O mode, or may execute in a multiplexing and async way with non-blocking I/O mode. To manage multiple execution flow and multiple tasks, we can use callback functions to execute our application code. We will see how the most popular callback mode works in Node.js and PHP in the next section. Callbacks, await, async, and versus coroutines. Okay. Şimdi devam edelim. Callback is always used to dispatch a long-running function and to be executed when the long-running function is finished, whereas await, async, and coroutines are doing the same thing. Await, async, and coroutines are doing the same thing. Callback is a way to sync different functions. These functions can be either synchronous or asynchronous. Only callbacks won't make any difference to your application. It makes difference when a callback function is asynchronous and has I/O operation inside the function, and also the process supports multiplexing. Okay. You might be confused about callback functions versus threads or coroutines. Şimdi callback fonksiyonlarla threadlerin ve coroutine'in farkları neler? Callback function is a user-defined function that should be called when a special condition is met. It could be sync or async depending on if the condition is the result of the dispatched function is finished. A thread or coroutine fiber responsible for running a piece of code, it is an independent execution unit. If you need asynchronous callback, you have to dispatch the execution of the function to another execution unit. Then wait for your condition to occur, and when it does, it calls your callback function. Because I/O is the interface to communicate with external components, you can also use asynchronous callback when you can dispatch the I/O to external execution units and wait for the I/O is ready or the result of the execution is finished. This is why there are many single threads asynchronous libraries such as Node.js or Redis. Because I/O is the interface to communicate with external components, you can also use asynchronous callback when you can dispatch the I/O to external execution units or wait for the I/O is ready or the result of execution is finished. This is why there are many single threads asynchronous libraries such as Node.js or Redis. Okay. Callbacks. Callbacks tell the executing function what to do when the async task is completed. Callback functions are the functions passed into a calling function and will be executed when certain events happen. In the most cases, after the calling function is completed. They are pointers of a function passed into another function as variables. Only callback function may block if there is no I/O inside the function or non-blocking. In real-world application, the major issue of callback function is mixing up I/O and the business logics. The whole logic of one task may be broken up into multiple pieces functions caused by multiple I/O handling. The nested functions make it difficult to understand. Doğru. It is also confusing when to use callback or not. You have to dig through the code base to find out if there are I/O operations within a function. To perform a series of operations, you may end up having to use recurring functions instead of just using a simple loop. The most famous issues of callbacks is the callback health and premise of dooms. Errors and exception handling and nested callbacks are uncomfortable to write, and this makes the code difficult to maintain and scale. Okay. Zaten şu callback hell'ler ünlüdür Node.js tarafında. Promise and then chain. It is more convenient to use promises compared with the callbacks. It is also called future. It is an object returned by the async task. Then you can tell the promise what to do after async task is completed. Bir tane asynkron fonksiyonu başlatıyor. Sonra bunu bittiğinde ise gidiyor result'ı bir değişken olarak tanımlıyor ve burada bastırıyor. Async and await. Async and await are the same as promise. Async returns a promise, await processes the execution, async function and waits for another async task to be completed. Okay. Whereas the promise then version looks like this. Tam aslında aynı iş yapıyorlar ama yöntemleri farklı. Async and await are more readable compared with the promise than chains because they look like asynchronous codes. Coroutines and fibers. People may call coroutines fiber. They are almost equivalent. The difference is if the fiber is always scheduled by a scheduler, but coroutine is not. Compared with the previous approaches to manage the async task written our code base, coroutines and fibers are more flexible and convenient. The async task codes look completed synchronously without any synthetic sugar. There is no limitation that you only can yield to another function. Once the async task is completed, you can pause the yield of the async task at any depth of the call stack or same call frame and resume. The advantage is about fair scheduling and avoiding one heavy task blocks all the other tasks running. Fair scheduling. You don't have predictive service and response time when you can make sure the scheduling is fair when using callbacks or synthetic sugar. Even in the ideal scenario, each task or request may require some time to process. If, on average, one request takes 10 ms to process. A single thread can process 100 requests per second. This means we don't have a predictive service and response time. If one request takes 1 second, all the other requests could be done in 50 ms and would have to wait and stall. Your application becomes slow because only one bad guy can destroy the performance of the whole thread. A very common issue in PHP FPM system or other systems, including the blocking I/O calls, is waiting for external I/O because we have almost no control of the performance of external services. This could make the performance or own services even worse. External servise sürekli çağrı yapıyorsun ama onları beklediğin için senin asıl thread'in, asıl prosesinde beklemiş oluyor komple böylece. So, the solution works like this. We want to be fair to all the requests from all the clients. If one request has to be slow and may take a long time, we just need to switch to other tasks without penalizing the other requests. So, all the requests have the predictive response time. The process time of the one task is not depending on the other requests. In Swoole PHP, we have event-based asynchronous I/O for the slow I/O and preemptive scheduling for the tasks. May take a long time on CPU to make sure the scheduling is fair scheduling. Okay. Şimdi devam edelim. Connect with protocols. 5. parttayız. In this part, we will discuss the most important concept, protocol, which is the language used by the communication, how the common use protocols work internally. Although you don't have to look inside the protocols when building your application, understanding how things work will help you avoid mistakes and build more efficient and reliable systems. Tamam, protokolü anlamak önemli diyor. TCP UDP protokolü. TCP is most widely used underlay protocol of modern internet applications. HTTP, WebSocket, HTTP2 are built upon TCP protocol. TCP is a reliable protocol that enables two processes, possibly on different machines. Each has a file descriptor to exchange data. Life cycle of a TCP connection. We have a describe of a life cycle of a TCP connection. There are many stages of an established TCP connection. Please check the previous sections about the life cycle of a TCP connection. Bunu da zaten bir önceki bölümlerde görmüştük. The cost of connection establishment. The problem that is not always thought about is the characteristic of TCP connection, slow start issue and the overhead of establishing a new connection or accepting a new connection, persistent connection, yani kalıcı. When maintaining a persistent connection, hardbed packages are necessary for the idle connection. When there are no application layer packages sending over the TCP connection, or the connection may be disconnected either by the client and server side or by the middle proxies routers. We have to take care of the life cycle of a TCP connection. In the case when a connection is disconnected by the remote peer, we should remove and destroy the resources related to communication and free up memory. Yani düşünsenize sürekli bir TCP connection oluşuyor ama client bağlantısı kesiliyor ama o bizdeki TCP connection objesi memoride tutuluyor. Bunların eğer client bağlantı kesilse bunların silinmesi lazım bir şekilde. Yani memorinin boşaltılması lazım bu yöntemle. Heartbeat packages can be sent through the TCP connection and ignored by the remote peer to keep the liveness of TCP connection. They can be triggered by the Swoole timer when you are building a TCP server. The good news is you don't have to manage the liveness detection of TCP connection in your application. Swoole server manages the TCP liveness detection closing for you. There are two settings in Swoole server: heartbeat check interval and heartbeat idle time. The interval to check the idle time of TCP connection, the max idle time of a TCP connection before closing. When a TCP connection is closed by Swoole server, you can free up the resources of the connection within the close callback function. Tamam, Swoole bunu 2 parametre bizim için hallediyormuş. Büyük ihtimalle bunların default değerleri vardır. Summary. Many application protocols are built upon TCP and UDP protocols, so the limitations and characteristics of TCP can be found on all of them. When designing your system, you should keep the characteristic of TCP in mind to choose either a persistent connection or short life connection, etc. Okay. HTTP protocol. You should already be familiar with HTTP 1.1 protocol. It is a text-based protocol with header and body. The protocol is ended with RN, and the header and body are separated with RN. Okay. We can look into HTTP protocol by creating an HTTP request inspector with Swoole server or use curl command. Tamam, basit bir HTTP 1.1 request ve response'unu göstermiş. It is a request and response protocol based on TCP. As we can see, the version of HTTP protocol is 1.1, HTTP 1.1 and Keep Alive. Bu Keep Alive'de bu az önce gördüğümüz TCP Persistent Connection'lar. HTTP 1.1 is the HTTP protocol used by most websites today. It allows multiple HTTP requests to reuse the TCP connections, but it doesn't support multiplexing like HTTP 2. You can send multiple HTTP requests at the same time via a TCP connection, but you have to send the second one after you have received the response of the first request. This is controlled by connection HTTP header from HTTP server. You can set it up by Keep Alive to reuse the TCP connection or asking the client to establish a new TCP connection for each request. For the server to have lots of traffic, the Keep Alive timeout value is one important param in the server. You can keep fewer TCP connections on the server by reducing this value or keep more TCP connections for the clients by increasing this value. In order to provide a real-time communication mechanism, server sends events are supported by the most modern browsers. Instead of polling by AJAX every period of time, the browser keeps a persistent connection to the server. The server is able to push real-time data to the browser in real time. We will show an example of how server send events works in Swoole in the following sections. Most people choose WebSocket as the real-time communication protocol for live chat system. SSC is not HTML5 feature widely used with HTTP 1.1, but it is suitable to be used over HTTP 2, which we will discuss later. Performance testing. We can roughly test the performance of a HTTP service with the tool wrkey. wrkey is a modern HTTP benchmarking tool capable of generating significant load when run a single multi-core PHP CPU. It combines a multi-thread design with scalable event notification systems such as ePOL on Linux and KQ on macOS. You can find more about wrkey at. If you have a HTTP 1.1 service you can test the performance of GET requests like this. Okay, güzel bir benchmark tool'u wrkey. Şunu alabiliriz aslında şöyle. Aklımızda bulunsun. Okay. We have created 4 threads and established 100 connections to send HTTP 1.1 requests to Swoole PHP server. From the testing result of this test, we can see the overall QPS of the HTTP service is 78,000 requests per second on my MacBook Pro, nearly 20,000 requests per second by one thread. You can also see the stability by checking the maximum latency and compare it with the minimum latency. It is worth noting by simply comparing the Hello World HTTP server doesn't mean you can get the same result when comparing with the real-world workloads. Summary. SSE and the other 2 popular protocols we will introduce in the following sections need to server-side keep and manage a large number of persistent connections, which is not supported by the PHP FPM stateless I/O model. This is a part of the reason why more and more developers are starting to investigate and use Swoole PHP. Tamam, sırf bu nedenden dolayı bile birçok developer PHP FPM'den Swoole PHP'ye geçiyormuş. Şimdi bakalım WebSocket protokolü. WebSocket Protocol is the most popular real-time protocol used by web applications. It establishes a two-way communication channel between client and server, handshake and establish connection. It starts from an aggregate from HTTP 1.1 protocol and some protocol-related headers. WebSocket headerları. The first handshake response is, to prevent the proxy cache, the client sends a base 64 encoded random key to the server and server responds to the hash as seg WebSocket accept header. The hash function appends a fixed magic string to the key sent from the client and applies SHA-1 hashing function, then encode it using base 64. Once the handshake is completed, the connection is switched into the bidirectional binary protocol. The client and server can send WebSocket data or text frames to each other. Okay. Protocol model. WebSocket protocol is also a request response model. The server side can also start requests like the client side. Once the connection is established, there are no HTTP headers required to include each data frame, so duplicate HTTP header data can be avoided. A WebSocket server can push JSON format data or the other format data to the connected clients. WebSocket protocol is widely used by live chat or web and mobile games today. Tamam. You can build your real-time application with WebSocket. WebSocket protocol is supported by most modern PHP web browsers and with SDK available in mobile applications or server-side languages. Let's look at JavaScript client. JavaScript client side WebSocket API. Okay. It is easy to debug WebSocket client. You can always print output with console log. In other sections, we will look at how to build WebSocket server side with Swoole. It's as simple as writing the client side. Client side yazmak kadar kolaymış. Bakalım. WebSocket protocol is the most commonly used real-time protocol. Build real-time systems. It's widely used by mobile games, web games, live chat system, or Internet of Things systems. If you add some real-time features to your website or application, WebSocket would be a simple and good fit compared with other more complex protocols. Doğru. HTTP2 protocol and gRPC. According to the web text, HTTP2 is used 48.5% of all websites as of October 2020. If you check your website, you may see it has already used HTTP2 if you are using the CDN that supports HTTP2 such as Cloudflare or Amazon CloudFront. Most CDNs support HTTP2 and do it transparently without your notice, and you don't have to do anything at your original server except plug into the CDN. The CDN's server and users with HTTP2 protocol and speak in HTTP 1.1 with your original server. HTTP2 is a pretty new HTTP protocol which is released 2015 compared with the HTTP 1.1 released in 1997 and HTTP 1 released in 1996. The size of the internet users grew a lot during the past 20 years. The original design of HTTP 1.1 is not fitting for today's internet usage, especially at the mobile and Internet of Things age. Tamam, günümüzde HTTP 1 ve HTTP 1.1 çok da uygun değil diyor. HTTP 2'ye geçmek lazım. HTTP 2 is a backward compatible revision of HTTP 1.1 and transparent to end users. It is secure by default. HTTP 2 protocol allows multiple concurrent communication on the same connection to better utilize the connection and resources and reduce the latency. Usually, the browsers only establish one connection per origin compared with more than 5 per origin if using HTTP 1.1. This can be better utilized TCP, avoid the TCP slow start issue of establishing each TCP connection, and also avoid the duplicate HTTP headers of each HTTP request. HTTP2 connections are persistent. The connection is not closed until there will be no further communication between server and client. Okay. HTTP2. HTTP2 is multiplexing protocol. Multiple independent data streams exchanges data between client and server within HTTP2 connection. The data stream is split into multiple frames with stream ID to identify which request or response it belongs to. Şurası da önemli. But HTTP2 is not designed as bidirectional protocol like WebSocket. Yani karşılıklı göndermiyorlar birbirlerine. The data stream is always pulled from the client side. Although HTTP2 has a confusing frame type push promise, it is not designed for data pushing from the server side. It only pushes the static assets such as images and JavaScript files. If you like to establish bidirectional communication between two peers, you can establish two HTTP2 connections and treat each peer as both a server side and the client side. Another way is to use server send events server push, SSE server push, also known as SSE over HTTP2, because SSE is reusing the established HTTP2 connection. There is no additional cost either at the server side or client side. We will also show how SSE works with Swoole in the other sections. Gördüğünüz gibi aynı anda birbirine veri sağlayabiliyorlar stream üzerinden. Client ve serverlar. HTTP2 also must have TLC supported. HTTP doesn't replace the HTTP 1.1 protocol but just modified the lower layer transport format. You can find more about the details of HTTP protocol at this website. HTTP2 protocol can be started. Burada buna baktım, bu çalışmıyor galiba. Bunu değişmiş olabilir bu URL. HTTP2 protocol can be started from the HTTP 1.1 protocol by sending the upgrade header and token. Okay. A server that supports HTTP2 accepts the upgrade with 101 switching protocol response, then the server can send HTTP2 frames. Apart from the request and the response multiplexing, HTTP2 has another powerful feature, server push. A server can proactively send multiple responses to the browser because HTTP 1.1 headers may take a large percentage of the traffic because of the growing number of cookies, etc. Duplicate HTTP headers transfer for each HTTP request can be largely saved with HTTP2. The binary protocol support also largely saves the data transfer between the server and client by compressing the plain text data. Try the hello world HTTP server. Yeni bir Swoole HTTP server'ı ayağa kaldırıyor burada. Şurada OpenHTTP2 protokol true demiş. Şimdi sertifika istediği için sertifikaları vermiş burada. Worker name, reactor name. The difference with an HTTP server is you have enabled the option OpenHTTP2 protocol and also enabled SSL. An HTTP2 request can also be started directly with HTTP2 clients such as curl or ngHTTP. For example, you can send an HTTP2 request on the Swoole to the Swoole HTTP2 server like this. Okay. The HTTP2 client sends some extra control frames before sending the HTTP request in the headers. In a headers, frames such as settings, priority. We can see the settings frame defines the max concurrent streams on the connection and also the frame window size. The HTTP response is sent by headers and data frames from the server side with a corresponding stream ID, same as the HTTP request. That is how HTTP2 is multiplexing and can serve multiple HTTP requests and response streams concurrently. Before the connection termination, the client also sends go away frame to notify the server side don't send more data. The stream ID initialized from client side are always odd numbers compared with the push promise stream initialized from the server side are always even numbers. In real-world applications or proxy, it is recommended to terminate the connection when the several streams are sending through the connection or there is a period after the connection is established. The client side should establish a new connection and retry when a connection is disconnected. In this way, the proxy or server can free the resources and memory and also avoid the runout of the stream IDs. Okay. Tüm her şey zaten kaynak tüketiminin azaltımına oynanmış bu HTTP 2 ile birlikte. gRPC. What is gRPC and what is RPC? RPC means removed procedure call. When a procedure or subroutine is executed in a different place, it can be a different process or a process on another server. RPC uses a client-server model. The request is initiated by the client and calls the server providing the service. RPC hides the internal message passing and communication from developers when you execute an RPC. It is the same as calling another function to the client stop. Okay. RPC. In order to exchange data, the request of the call and result of the call, a kind of protocol is required and agreed by both client-side and server-side. RPC is always provided by the RPC frameworks. So, hold on a second. Okay. In order to exchange data, the request of call and result of the call, a kind of protocol is required. Okay. And agreed by both client-side and server-side. RPC is always provided by the RPC frameworks dedik. So you can exchange data between different systems, even written with a different language on a different platform. gRPC is an open-source RPC framework initially developed at Google in 2015. It is built upon the takes the advantages of multiplexing HTTP2 protocol and high performance and more compact serialization protocol buffers. Okay. Bunu da hemen not alalım. gRPC. Compare with JSON payload with 59 bytes. The protocol buffers uses only 14 bytes and save lots of network bandwidth and also save lots of CPU to parse the JSON payload. Yani protokol buffer kullanarak aslında JSON'dan ne kadar kar ettiğimizi burada anlatmış. Aynı veriyi 59 byte'la gönderirken JSON payload olarak aynı veriyi protokol buffer'la 14 byte olarak gönderiyoruz. Böylece hem network bandwidth'inden birçok kazanım sağlıyoruz hem de CPU'da bu JSON'ın parse edilme süresini azaltıyoruz. The downside of a protocol buffer is it is not human readable. Tamam, bu protokol buffer'lar JSON gibi human readable, yani bizim okuyup anlayabileceğimiz yapıda da değillermiş. You have also used base 64 to encode when using in the browser environment. Okay. The gRPC Go stacks. Unix domain sockets, TCP, HTTP2, gRPC core, generative stuffs, application. Okay. Protocol buffers is a method of serializing structured data exchanged over gRPC. It is smaller and faster compared with XML or JSON. You can also find Apache Thrift by Facebook or Bond Protocol by Microsoft to build a PRC protocol. An example gRPC protocol over HTTP2 looks like this. Okay. We can also see how gRPC works as the communication layer for the multiple language architecture. We will show how you create a simple gRPC client server with Swoole PHP in the other sections. Web performance. Most popular websites, browsers, and CDN support HTTP2. Most spiders, some Android browsers are still using HTTP1, so you shouldn't remove HTTP1 at this stage. Enabling HTTP2 for your and users can improve the performance because there is a limitation of HTTP1 connections. Nowadays, the complex web pages may be exceeding this limitation, but there is no such problem with using HTTP2. Okay. In the age of mobile and HTTP2, the old ways of doing web performance optimizing on HTTP 1.1 may be worked. Domain sharding and asset concatenation are no longer applicable or need to be reworked. If you are not familiar with domain sharding, it is a technique to send more concurrent requests to serve because of max connection number on each domain. The idea is to serve the same asset with multiple different domains. Asset concatenation is the technique to combine multiple JavaScript or CSS assets into the one file to avoid sending too many connections to the one domain. You don't have these issues when using HTTP2 protocol. Additional thoughts. If you are building an internal RPC upon HTTP2 such as gRPC, Envoy proxy is highly recommended. It manages the connections between services and provides service discovery, load balancing, reconnect and retries. You can also access the metrics provided by Envoy proxy like request rate, response time, etc. Bu şey herhalde sidecar proxy'den bahsediyor burada. Alternatively, you can choose application load balancer on AWS supporting to end-to-end HTTP2 and gRPC. There is also another HTTP protocol adapted by some infrastructure recently, which is HTTP3. It works in a way similar to HTTP2 but using encrypted UDP protocols and further improve the HTTP performance for large websites. Okay, summary. In this section, we have learned how the HTTP2 protocol works and why people are creating a new HTTP protocol. You can also use the RPC on HTTP2 or gRPC as an RPC layer for your distributed system. Because HTTP2 is a new protocol, the client libraries on server side may not implement all the features defined by the protocol spec. When you are building RPC based on HTTP2, you have to test the corner cases such as graceful server, side shutdown, reconnect and retries at the client side, etc. Custom protocol. Şimdi nerede dursak diye bakıyorum da. Swoole runtime and internal. Yavaş yavaş Swoole'a gireceğiz sanırım. Tamam, bence buraya kadar okuyalım. Part 6'e kadar. Geri kalanına bir dahaki bölümde devam ederiz. Hızlıca şurayı bitirelim. Custom protocol. We can create a custom compact protocol based on your application and requirement. Before you start, you should always think of using the popular protocols. Because of the ecosystem, there will be lots of limitations of your protocol, such as firewall settings, cache support, proxy support, client-side support, etc. Okay. A custom protocol can be used internally in your organizations or your RPC system. You should have to control both server-side and client-side implementation. Another situation is you have to design a new service like Memcache or Redis, Kafka for performance reasons. You can't use existing protocols. You'll not only have to create the server but also have to build the libraries potentially for multiple languages. Another reason we like to include this section is sometimes if there is not a Coroutine supported client for a service, we have to create the clients with a custom protocol. Custom protocol upon TCP. There are three common ways to design protocols upon TCP. The first approach is based on fixed length. The second approach is based on fixed header and flexible length. You can also create based on end-of-file separator. When designing a new protocol, you have to balance these factors: human readable, easy to implement, and performance impact. End-of-file based on protocol or TCP. Most text protocols use an EOF string to mark the end of the data package. We have to make sure there is no EOF within the package. This approach is used by HTTP, Memcache, FTP, SMTP, HTTP users as the EOF string. EOF. Prefixed length protocol over TCP. Another common use method is by setting a prefix length, a header with the body length information, then append the body to the header. In the real world protocol, the header may contain more information such as checksum, etc. HTTP response header sometimes includes the body length info if the response is not sent with trunk mode. The performance of parsing prefix length protocol is high because we can quickly get the package length, then get the whole package without scanning the payload for the special characters, marking the end of the package. Swoole server provides convenient ways for TCP-based package parsing the splitting. It only sends the whole TCP package to the worker processes when it is completely received. You can use the following settings to easily create your package parsers. Bilmiyorum, buna gerek duyar mısınız? Ama böyle bir şey de varmış diye aklınıza bulunsun. These parsers can also be used at the TCP client side. Use the same protocol to parse the packages sent from server side. We will show you how to design very simple custom TCP protocols based on prefix length in the section Design Custom TCP Protocols. Summary: if you can't find existing protocols which can solve your problem, it is not recommended to create a new custom protocol. Ya burada dediği gibi zaten buna çok önerilmeyen bir şey. Çok edge case bir senaryo yoksa. Swoole provides the function to enable you to do so in the case when it is required. Because the protocol is used for communication, we should use the common used protocol if possible to reduce the overhead to other side. Yani mümkün olduğunca custom şeyler yapmayın. Piyasadaki standart protokolleri kullanın diyor kısaca. Okay, Swoole runtime and internal. Tamam, şuraya da okalım. PHP extension'da bırakalım. Swoole runtime and internal. In this section, we will introduce how Swoole integrated with PHP virtual machine and PHP ecosystem. Swoole is a C and C++ application with PHP programming interface and built up on the PHP ecosystem and installed as a PHP extension. You can write PHP code to power the high-performance Swoole framework. Okay. Swoole PHP extension'da, yani 148. sayfada bırakalım. Bugün şu konular bayağı derine indik. Ama birçoğunda aslında o PHP örnekleri falan vardı. İşte soketler oluşturma, ne bileyim custom protokoller falan. Bunları aslında gerçek hayatta hiç yapmayacağımız şeyler ama bunları en azından bilmemiz gerektiğini ve aklımızda bulunması gerektiğini anlatmış bir şekilde. Kısaca mesela notlarımıza baktığımızda neler gördük kabaca? İşte memory management'ı gördük. Stack memory, heap memory. İşte mesela stack memory işletim sistemi tarafından kısıtlı bir space'e sahipken ve bunu CPU tarafından yönetiliyorken, heap'te ise doğrudan bizim uygulamamız tarafından yönetiliyor ve bunu dinamik bir şekilde genişletebiliyorduk. Memory'nin kaynağı, yani memory'nin yeri olduğu sürece. Sonra Linux prosesleri gördük. Linux thread'ler vardı. Linux proseslerde neydi o? Bir tane system call vardı. Forking. Forking system call ile birlikte subprosesler oluşturabiliyorduk. Eğer ki bir subproses oluşuyorsa bu prosesin tüm değişkenleri ve konteksti kopyalanıyordu yeni subproseslere. Ve bu subproseslerde yaptığımız değişiklikler parent'ı etkilemiyordu. Thread'lerde ise tam tersi. Thread'ler proseslere göre daha hafifti Linux'te. Ve bu thread'ler ortak virtual memory space'leri kullanıyor dedik. Yani bir thread'de yaptığımız değişiklik diğer thread'leri etkiliyordu. Yani bunlar ortak yerleri kullanıyor memory tarafında. O yüzden bu subproseslerle thread'ler arasındaki farkı bilmek önemli. Sonra soketleri gördük. Bu işte blocking, non-blocking'ler veya async'ler nedir onlara baktık. Sistem ve network katmanında. WRK diye bir performans testing'den haberimiz oldu. HTTP2'ya çok değindik. Özellikle HTTP 1.1'in yerine gelmediğini, HTTP2'nun ona özellikler getirdiğini görmüş olduk. Yani ikisini de aynı anda kullanabiliyoruz aslında. HTTP2'nun işte multiplexing ve singleplexing nedir? Onlara bakmış olduk. Bunu bir önceki bölümde de görmüştük. Ama HTTP2'yu bugün daha detaylı bir şekilde incelemiş olduk. Ardından RPC ve gRPC'ye baktık. İşte gRPC neydi? RPC framework olarak çalışan Google tarafından sanırım 2015'te, hatırlamıyorum tam tarihini. Evet, burada yazmışız zaten. 2015'te oluşturulmuş bir RPC framework. RPC neydi basitçe? Başka bir makinedeki sanki aynı makinedeymiş gibi bir prosesi çalıştırmak kabaca. Çünkü network üzerinden bunlar iletişime geçtiğinde çok yavaş olacağı için RPC soketleri kullanarak, yine server client mimarisi var. Bunlar sürekli birbirine bağlı bir RPC server'ına. Bir tane proses çalıştırmamız gerektiğinde farklı bir server'da doğrudan gidip bunu çalıştırıyordu. Sanki bir monolit yapıymış gibi. Şu anda ise Swoole PHP extension'dayız. Bir sonraki bölümde buradan devam edeceğiz. Bakalım bizi bir sonraki bölümde neler bekliyor olacak. Bir sonraki bölümde görüşmek üzere o zaman. Herkese bay bay.